Okay, we're going to look at graphing exponential functions today, and exponential functions take this form of f of x is equal to, let's use a and then b to the x minus h. We're going to put plus k back here. And so the thing with exponential functions is they get really big really fast. When you hear something growing exponentially, this is what they're referring to. How you can identify one from an equation is you'll see the variable is up in the exponent. And it leads us to an exponential equation. These functions have some properties. We are going to call the initial value is going to be 0, 1 of the parent function. And so that will be our our starting point before we shift things around. So let's kind of look at this graph, y equals 2 to the x. And so if I plug in 0, I get 1. And for any base, like if I did, let's make a little xy table here. If I plug in 0, I get 1. And I could change the base, which is the 2, to any value. And I plug in 0 and I still get 1, because anything to the 0 power is 1. And so that each exponential function will start by going through 0, 1, and then we shift around from there. There's also a horizontal asymptote at y is equal to k. And so in this case, k is 0. There would be like a plus 0 out here. And so this graph of this parent function has a horizontal asymptote that is on the x-axis. So that's that line the graph will approach but never cross. And this makes sense if you think about like an xy table, because you could never get a negative number. If I plug in 2 to the, let's say like negative 3, well, negatives just move things to the other side of the exponent, or sorry, the other side of the fraction if they're in the exponent. So this value, like, y is never going to be negative. It'll get really close, and it never can't even be 0. It can get really close, but never actually get there. So it's always going to remain above the y-axis. To get another point, let's plug in a point or two. Let's plug in some y values, and we'll see how quickly this goes up. So if I plug in 1, then 2 to the first is 2. 2 squared is 4, and then 2 cubed is 8, and then it'd be 16 and 32 and 64 and so on. So very quickly we'll get off the graph. So for that reason, like when you graph these, just put one point is fine, and then a sketch of the curve. If you want to get some other points, that's okay, but pretty quickly you'll get, it's kind of too big to graph. So 2, 3, 4, 5, 6, 7, 8, even at 8 we're kind of getting off the page. And then over here the values are going to get really small, so it'll approach the axis and look like this. Okay, then we'll talk about domain and range. So the domain of these functions, that's like if you look left to right, and domain's always tricky, but these go forever to the left and forever to the right. And the range is going to go from the bottom to the top, and that will deal with k. So the range, in this case, the smallest value it is close to 0. Use a parenthesis because it's never actually 0, and then it goes to infinity. Okay, so the h and k and a hopefully look familiar. These are our same transformations. So a is a vertical stretch if it's greater than 1. Let's actually write that first up here. So if a is bigger than 1, then it's a vertical stretch. And if a is less than 1, then it's a vertical compression. H will shift the function left or right. So it's a translation. Horizontal translation, left or right, and you're going to do it's the opposite of the sign. And then K, that's that horizontal asymptote, but it's also the vertical shift. And you will keep the sign. So it's going to go up and down, and we will keep the sign. So looking at this example, I'm kind of squeezing some stuff in. Whoops, don't cross it out. So looking at this example, g of x is equal to 6 minus 3 to the x power. Oh, and actually I forgot about the negative. A negative will reflect it. A negative in front reflects it over the x-axis. So this 6 is the k value. That's going to move it up 6. 3, 4, 5, 6. That is also the horizontal asymptote. So let's go ahead and state that the horizontal asymptote is y is equal to 6. And I would put that on your graph first. The other way to think about this is this point. So we start with 0, 1, and we move that point up 6. So 1, 2, 3, 4, 5, 6, 7. Oops, sorry, I counted to 7 because I'm on 7. So that point would be there. Now the difference there, and let's put an X there instead because we're not quite done, is this graph is going to reflect over the y-axis. Actually, let's reflect that first, sorry. We can kind of make sense of this either way, but it'll make more sense to reflect it first. Draw that a little better. So if I reflect this is going to reflect over the x-axis. So I take this point 0, 1, and because this negative right here, that's going to be my reflection. So it's going to reflect over here, and then move up 6 from there. So 1, 2, 3, 4, 5, 6, and there's your point. Also, that reflection, instead of coming up here and going up, it's going to grow away from the horizontal asymptote down here. So my domain is all real numbers, and it's always all real numbers for these exponential graphs. In my range, now my bottom, it goes forever on the bottom, so it goes to negative infinity on the bottom, and then at the top side, where it maxes out, is up at 6. But it won't get there, so use a parenthesis. Okay, so on your graph, here are the things that we want to see. The minimum stuff we want to see anyway. We want to know what the horizontal asymptote is, so make sure you state that and then actually graph it. We want this point. If it moves left, right, up, down, reflects, whatever, we want to know where that point ends up. We want the sketch of the graph itself, and then a domain and range stated is always a good thing.